Okay. Looking at another example, example number 7, still on empirical and molecular formula calculation. Talking about examples, looking at this very fantastic one. The leaves and seeds of carica papaya pawpaw are known to contain a potent amobicide with molecular formula C28H50N2O4. Calculate the percentage composition of the element and suggest an empirical formula for the compound. So in this case, as a chemist, we are not concerned about the leaves and seed. We are concerned with what is the percentage composition of the element present in the molecular formula. And of course, like I said, in this case, the molecular formula is given, but we don't know the empirical formula. In this case, the molecular formula is given, but we don't know the empirical formula. And we cannot get to the empirical formula without knowing the chemical composition. And so that is why the percentage composition is required. And then, using the percentage composition, we are asked to suggest, meaning to calculate or determine the empirical formula as well. And so in that case, in this case, where the molecular formula is given, you don't need to go to the formula of E.F. You don't need that now. To be equals to M.F divided by N. The reason why this formula cannot go through this is because number 1, the N, which is the molecular weight of the compound, is known. You can determine the molecular weight of the compound from the molecular formula, but we cannot determine the empirical weight. And of course, we cannot use this. Because we cannot get this, the N, and we cannot get E.V, empirical formula, we cannot determine the empirical formula from this, because we can only get the empirical formula, which is this. We don't know the weight of the compound via mass spec, and so we cannot find it. We cannot find this. And so since we cannot find this, and we cannot find this, and we don't have this, we cannot get it at all. So we have 2 missing variables. So in that case, we'll go back to our previous step, which I cited in example number 6. So the example number 6 rule will be applied in getting our result. So the rule in example number 6 I pointed was 1. We have 5 of them. 1 I pointed was you must get the ratio of each of the elements. You get the ratio. After the ratio, you need to get the relative atomic mass of each element. And then after getting the relative atomic mass of each element, you proceed to step number 3, getting the weight of each element. And then after getting the weight of each element, you proceed to step number 4 that said get the overall weight of the compound. After arriving at the overall weight of the compound, finally the 5th rule said get the percentage. How do you get the percentage? The weight of the element over the overall weight of the compound times 100/1. That will drop you at your percentage composition. And when you arrive there, of course, get your ratio back. And then, of course, you land at your empirical formula. And so, let's see how it goes now. So, first of all, we said ratio. You get the ratio of each of the elements. C is there, H is there, N is there. and then O is their oxygen. So we get the ratio. That's the first step. So, sorry, get solution first. Let's be very sure what we're doing. So we proceed. Get our solution done. Solution to our question. First, we say get the ratio. The ratio we have C, H, N, of course, and O. It's an organic compound. Apart from carbon, hydrogen, we have nitrogen and oxygen and other elements. So in this case, the ratio here from this, we have 28 for carbon, we have 50 for hydrogen, we have 2, of course, for nitrogen, and then we have 4 for oxygen. This is the ratio. Step 1 has been done. So we are done with step 1 by sourcing out the ratio of each element. Number 2, get the relative atomic mass of each element. So, like I said, the atomic mass of carbon is, of course, 12.01. Relative atomic mass of hydrogen, of course, is 1.01. And of course, the relative atomic mass here, of course, we know is 14. And then, of course, oxygen is 16. So, do that. In our example number 6, I pointed out that you multiply the ratio by the relative atomic mass. So these values will be multiplied. So multiply this. When you multiply this, it will automatically drop you at step number 3, which is the atomic weight, the weight of each element present. Weight of each element present. So when you do this multiplication, to drop it to step number 3, which is weight of each element. That will take you about this many 2 steps. So multiply 28 by 12. If you do that, you'll be arriving at 366.28. 336.28 grams. Of course, you multiply this will give us, of course, 50.5. Of course, if you multiply this will give us 28. And then, of course, do this time, this of course is 4. So, these are step number 3 is done out of the 5. So, this is the weight of each element present. So, the next thing is to get the weight of the overall compound. In arriving at the weight of the overall compound, you sum. So sum all the weights. To get the overall weight. So this will give us 336.28 plus 50.5 plus 28 plus 64. And if you do that mathematically, you have 478.78. 478.78 weight of the overall compound. Finally, we get to step number 5, which is our final step in arriving at percentage completion. So, in doing that, we are going to be having, for carbon, we have 336.28 divided by 478.78 times 100. We do that for hydrogen. That's percentage completion. We'll do that for hydrogen. If we do that for hydrogen, we will also have the hydrogen by weight percentage will be given to us as 50.5 all divided by 478.78 times 100 over 1. We do that for nitrogen, percentage composition of nitrogen, or same question, we have 28 all over 478.78 times 100 over 1. Do that for oxygen. Do that for your oxygen. You're going to be having by percentage. You're going to be having oxygen, of course, is 64 all over 478.78 times 100. So let's see what get there. If we do that mathematically by percentage, we will have that carbon is equal to 70.23%. Hydrogen will give us about 10.55%. Nitrogen will be giving us as 5.85%. And of course, finally, our oxygen will give us 13.37. Oxygen will give us 13. Percentage oxygen will give us 13.37%. So, by percentage, we have arrived individually at this. So, from this, we can deduce that percentage carbon in the compound is 70.23. Percentage of hydrogen, of course, is 10.55. Percentage of nitrogen, of course, is 5.85. And of course, percentage of our friend oxygen is 13.37 individuals. So the percentage composition is final. Just take your step, 5 basic steps to arrive at successful. So the next question was suggest the empirical formula. So in suggesting the empirical formula, of course, from the percentage composition, we can deduce the empirical formula. How do we do that? We set up our ratio as usual, which is what? Carbon, hydrogen, nitrogen, and of course oxygen. So by that, by percentage composition, by ratio, we have that percentage composition will be divided by the relative atomic mass of each of the atom present. So we have 70.23% of carbon divided by 12. Of course, 10.55 of hydrogen divided by 1. And of course, 5.85 of nitrogen divided by 14. And of course, we have 13.37 of oxygen divided by 60. In this way, we are going to be arriving almost close to our empirical formula suggestion. So if you do that mathematically, you have that this will give us 10.55. And then of course, if you do that of carbon, you're going to be having 5.85. Then if you do that of nitrogen, you're going to be having 0.42. And then if you do that of oxygen, you're going to be arriving at 0.83. Now, this is where we come in. Here we are supposed to be multiplying by the smallest. Sorry, dividing by, in this step now, you will follow the rule of dividing by the smallest number. Among these, which of them is smallest? The smallest here is 0.42. Is smallest. So you divide through by 0.42, and then you divide all through by 0.42. 0.42. If we go with 0.42, we are going to be having 1. If 0.42 go through that by 10, you are going to be having 25.11. 25.11. This going to this, of course, we are going to be having 13.92. And then if this go into this, of course, we're going to be 1.98. Now, see, you have to go through them. Arriving at this point, two things are involved. Now, going through multiplication by inserting whole number, none of them will give us a whole number. None will give us a whole number. And so, in that way, we go through the rule of rounding up or rounding down of numbers. And if you choose that, we'll round this up, double to what? 14. Round this down to 25. And then this, then round this up to 2. So we have this is to this, is to that. So our empirical formula by suggestion should be that C14, H25, nitrogen 1, and of course oxygen 2. This is our B dot F. So empirical formula is C14, H25, NO2. That's empirical formula. That is the B that contains potent amino peside with the formula of C28, H50, N2. Thank you. Stay tuned.